Hello, grade 8. This is Mrs. Lopez, and today we are starting our new module, Module 1. Very exciting, I know. And we are going to talk about something totally different than what we did in Module 4. We are going to learn about exponents, exponential notation, scientific notation. We will learn operations with exponents and all that fun stuff. But today it's our first lesson, and that is exponential notation, lesson 1. So let's go ahead and start with something very easy first. So let's say I write 3 plus 3 plus 3 plus 3 plus 3. We know this since our grade 1, right? I'm adding 5 units or 5 summands of 3. Is there a way to rewrite it using a more efficient method? There is a way, and we learned it in grade 3. This is 5 times 3, right? We are using multiplication as repeated addition. This is 5 groups of added 3's together, okay? But what if we have something like this? 3 times 3 times 3 times 3 times 3. How would I call that? Is there a more efficient method of doing that other than multiplying 3 by itself 5 times? And there is a method. It's called exponential notation. So instead of the question mark, we can write it as 3 to the fifth power. Okay? 5 is called an exponent, and 3 is called the base number. Exponent tells us how many times the base number is multiplied by itself. So when I'm looking at 3 to the fifth power, that's how we call it, 3 to the fifth power, I know that 3 as a base number is multiplied by itself 5 times. So it basically is 3 times 3 times 3 times 3 times 3. Okay? So let's say 5 to the sixth. 5 to the sixth. 5 is the base number, 6 is the exponent. The exponent is telling us how many times 5 is multiplied by itself. So 5 to the sixth is 5 times 5 times 5 times 5 times 5 times 5, repeated by itself 6 times. Okay, or multiplied by itself 6 times. Okay, if I take a fraction, let's say I have 9 sevenths to the power of 4. That is 9 sevenths times 9 sevenths times 9 sevenths times 9 sevenths. And that is repeated 4 times. Okay, so that is basically the whole point of exponential notation. Exponential notation is just a more efficient way of rewriting repeated multiplication. Okay, so any number to any power, let's say here's the rule, right? Any number to any power is going to be that number multiplied by itself x times x times x, no matter how many times, multiplied by itself n times. Okay, so here's the rule. I can take any number and put it into any power, and that it will mean that I'm taking that base number and multiplying by itself as many times as the power is telling us. Okay, so let's go ahead and do very quickly some exercises here. Um, let's say I have negative 4 elevenths to the third power. How am I going to write it? I'm going to write it as negative 4 elevenths times negative 4 elevenths times negative 4/11. I'm rewriting it by itself 3 times and I'm multiplying it by itself 3 times, right? So that is 3 times, okay? What if I have negative 2 to the sixth power? That's exactly the same thing, right? I'm taking negative 2 and I'm multiplying it by itself 6 times. Okay, that is what negative 2 to the sixth power is. Let's take a decimal. 3 and 8 tenths to the fourth power. Exactly the same thing. So it 3 and 8 tenths times 3 and 8 tenths times 3 and 8 tenths times 3 and 8 tenths. Okay. Notice also that we are here using multiplication as an x. Even though we learned not to do that earlier, now in exponential notation, we actually do use x as a multiplication sign. So this is just as a side note. Now, what if, let's see, what if I had something like negative 4/11 to the third power? How would I write it and how would it look like? Notice that I did that negative 4/11 to the third power before. Is that going to be different or is it not going to be different? Well, let's take a look what is exactly taken to the third power. Actually, to the third power, I only have a 4 here. It's not even, the negative sign doesn't even apply to that 4. 4 is taken to the third power. So it's going to be the opposite of 4 times 4 times 4/11. That's what it's going to look like. So this is a little bit trickier, right? Because we don't have parentheses around any of this. It means that negative is not included, and it means that the exponent only applies to the number, to the base number that it's above. Okay? If I put parentheses around the whole fraction, I would include the whole fraction in it. Okay, so that's one very important thing that you need to know. All right, so right now it's time to try some exercises. I'll have you do numbers 1 through 10 by yourself and then get back together and check the answers. So we are back together now and just very quickly going over all of my answers and compare them with yours. So 4 multiplied by itself 7 times is 4 to the 7th power. Exercise 2. 3 and 6 tenths multiplied by itself to the power of 47 is multiplied by itself 47 times. In exercise 3, negative 11 and 63 hundredths multiplied by itself 34 times is negative 11 and 63 hundredths to the 34th power with parentheses around negative 11 and 63 hundredths. Number 4, 12 to 15th is 12 multiplied by itself 15 times. Exercise 5, negative 5 multiplied by itself 10 times is negative 5 to the 10th power. Make sure to put parentheses around negative 5. Exercise 6, 7 halves multiplied by itself 21 times is 7 halves to the 21st power. 7 halves taken into the parentheses. If you don't put parentheses around 7 halves, it will mean that only 7 is multiplied by itself 21 times. Exercise 7, negative 13 to the 6th power. Exercise 8, negative 1/14 to the 10th power. Exercise 9, x multiplied by itself 185 times is x to the 185th power. And exercise 10, any number to the nth power is that number multiplied by itself n times. Okay? All right. So now let's go ahead and look at exercise 11 together. So, will these products be positive or negative? How do you know? All right, so what we are going to do, we are going to look at it this way. I'm going to rewrite -1 times -1, and that is going to be +1, right? And then I have another group of -1 times -1, and that is also a +1, right? And then another and another and another. So all 12 -1s are going to have a pair that is going to multiply by itself and going to be equal to +1. So actually my answer is going to be positive, right? Because every single one has a pair that makes a +1. Okay. What about when I have -1 to the 13th power? Okay, so if I have that, I will have 12 of them that has a pair and one -1 that doesn't. So even if I have all of these positive ones, I'm going to multiply it by one negative. It means I'm going to multiply different signs, and my answer is going to be negative, right? So this answer is going to be positive, and this answer is going to be negative. So the question is, do I even have to do all of these calculations to find out the sign of my product? I don't, because I can look at the exponent and I can see if that exponent is odd or even. If it's even exponent, it means I will have an even number of the numbers that I'm going to multiply together. That means I will always have a pair to pair it up with to make a positive answer. When if it's an um, odd number of an exponent, it means that I will have a one number that is going to be negative while all the others are going to turn positive, right? That means that I will still end up with a negative answer. Okay, and I just answered exercise 12. It is not necessary to do all the calculations because I can only look at the exponent and see if it's if it's an odd or an even number. So in this case, exponent is odd means that the product is going to be negative. And when I have an even number of the exponent is even, means that the product is going to be positive. Okay, that was easy. Now let's move on to the next one and see exercise 13. I want you to actually do it by yourself. Just pause the video quickly, do it by yourself, and then get back. Okay, so here's your answer. If an n, an exponent, is a positive even number, even means every number has a pair, right? Then my product is going to be positive. If n is an odd number, then it's going to be negative. Okay, number 14. Josie says that -15 multiplied by itself 6 times is going to be -15 to the 6th. Is she correct? Think about it and then we'll get back together. All right. Well, she's actually not correct because we have to have parentheses around -15 to the 6th power. Otherwise, it's going to be a different number. What -15 to the 6th is the opposite of 15 multiplied by itself 6 times. Okay, that is what is multiplied by itself 6 times. This is a little bit different than what I have here. And also, if you take a look at it, because the exponent is an even number, it means I will have a positive answer, right? When I have it this way, negative 15 to the 6th is going to be the opposite of 15 to the 6th power. That means my answer is going to be negative. So she is not correct. And this is why. All right, exercise 15. This one is a little bit different. Here we are going to try to rewrite each number in exponential notation using specific bases. What does that mean? If let's say I want to write a 9 in an exponential notation using 3 as a base, I'm going to actually pretend that 9 is a 3 multiplied by itself, right? Sorry. So I'm going to divide my 9. I'm going to pretend and make a factor tree out of 9. And I know that 3 times 3 is a 9. So 3 is multiplied by itself twice. That is going to be 3 to the second power. All right. If I'm taking a look at 27, 27 I can rewrite as 9 times 3. So the 3 is the base, but then 9 isn't. So I'm going to divide 9 again until I get that 3 all the time. So when I see that 3 is multiplied by itself 3 times. So it will be 3 to the power of 3. Okay, so if I look at the 81, I can make it as 9 times 9, right? 9 is not a base of 3, so I'm going to keep dividing that 9, and I will get 3 times itself 4 times. That means I have 81, and I can rewrite it as a 3 to the 4th power. Last one here, 243. Because right now I can't tell what is going to be multiplied to get that 243. So I'm going to, since I know that it has to be a base of 3, I'm going to divide 243 by 3. And 243 divided by 3 is 81. Okay, so right now I already have that 3 and I can circle it. But 81, I can continue dividing. So it's 9 times 9 and 3 times 3 and 3 times 3. Now I have 5 3's multiplied by itself. So that means it's a 3 to the 5th power. Okay, so these are all the exercises, all 15 of them. Next one would be the problem set, and that's what we are going to do in our next class. All right, so I hope that made sense, and I will see you in the next one.